Hi there, this is Math 7, Unit 6, Lesson 20, Combining Like Terms. This is part 1 of 3, so there actually are 3 lessons in a row that deal with combining like terms. And so it says, let's see how we can tell that expressions are equivalent. The first part is why is each true. We want to explain why each statement happens to be true here. And so the difference between this first statement and the second statement is that we can see that it's added some parentheses here with the 2 and the 3. Now these are all addition, right? 5 plus 2 plus 3, they're all addition there. And so because they're all addition, we can use the associative property of addition to basically add things in a different order. Okay, it doesn't matter which one we do first since it's all addition. I can go ahead and do 5 plus 2 is 7, and 7 plus 3 is 10. 2 plus 3 is 10. Or I could do this and go, this is 5 plus the 2 plus 3, which is 5, and that still equals 10. So the order doesn't matter, especially when I'm dealing with addition there. When I look at this next one here, 2a, I can see that I'm dealing with the distributive property in this case here. And the reason we say that is because I can take the 11a and the 11a minus 2a, and we can do distributive property kind of backwards, right? Where we find a factor. In this case here, the factor would be a, and I have an 11 left here and a minus 2 left there. And if I do what's inside the parentheses, I end up with a times 9, or that's the same as being 9a if we change the order around there. So it's equivalent there. So using the distributive property and rewriting things, we can show that these are going to be equivalent expressions here. For this one, we have 7a plus 4 plus 4, and here we have a minus 2a, and here we have adding a minus 2a. And so what we've done is we're adding the opposite, right? We're going to add the opposite here. We're turning this minus 2a into add the opposite. And by doing that, we're able to move it around because of the addition with the associative property, because of the commutative property, it allows us to change the order around and put it in a different spot because it becomes an addition problem at that point there. And so that's how that's able to work and why it's true. And finally, this last one, 8a minus 8a minus 8 is equivalent to 8. Again, if we were to take this and then distribute the minus sign throughout the whole thing, I would rewrite this as 8a minus 8a, and a minus times a minus becomes a positive 8. And so an 8a minus an 8a goes away, so that eliminates itself, and all you're left with is simply 8, which is equivalent to being 8. So it just works out that way. When we turn the page, we're looking at an expression that Diego and Jada are trying to write with the fewest terms that is equivalent to what's here. And this is really a lengthy way of trying to talk about how we can really understand what do all these little terms mean. So Jada, first of all, thinks that 10a plus 1b is equivalent to that, but Diego thinks it's 4a plus 9b. So only one of them is probably right, or I guess both could be wrong, but we're taking this expression right here, and what we want to do is we want to show how we can take this expression, and down here we're going to break it apart row by row, bit by bit, and rearrange it until we get to a point where it shows us that it's going to match Diego's answer down here, which is 4a plus 9b. So how do we get that equation there? And we can see what they're doing is we're taking a 7a, and we're breaking that apart into this little chunk right here where there are 7 a's. 1, 2, 3, 4, 5, 6, 7. We're taking the 5 b's and we're clustering them right here as 5 different b's. And then we're subtracting the 3 a's, subtracting 3 a's. So there's my 3 a's there. And then here we have 4 b's which go along there. And so what they're going to do is we're going to take this apart and we're going to show how we can move things around by rewriting it, restructuring it, and then basically reduce it down or simplify it to being just 4 A's and 9 B's. And that's the idea. So the big difference here, first of all, we can see with the A's, we have this group here of a negative, or subtracting 3 A's compared to the 7 positive A's here. And so what they did in the second line is they took the 7 A's and they broke it apart into a group of 4 and to a group of 3. And they're going to do that so that we can take this group of 3 here, these minus 3 and those positive 3, and eventually combine them so that they go away. And so what you can see is this group of 4a's goes there, and we take the 3 plus a's there and the 3 minus a's there, and we put them side by side, so that this little cluster of 3 plus a's and minus 3a's are going to be eliminated. And that's part of the idea there. The 4a's here that are left continue to move down and down and down until it just becomes the 4a. And that's what's happening with the a's. When it comes to the b's, we can see we have 5 here and 4 there. They just keep the 5 here, the 4 there, nothing's been done with it. And then once the a's are figured out, then we're combining the 5 and the 4 to make it one giant group of 9, where you end up here with 9 right there. And so this is what's taking place. Now this is a long way, and most likely you would not want to just expand all of your variables to make a problem like this. All right, there's much faster ways of doing it, but this is a visual way of showing you row by row how we get an equivalent expression to the one before it, and it's basically simplifying down to that point there. So again, here's another way we can rewrite the expression, and here we have the same idea. We're taking the minus 3a and turning it into adding the opposite, right? So we're good there. And then what's happening is, because of the commutative property here, we're going to change the place so that 3a comes right here next to these a's. So the a's are grouped together and the b's are grouped together. And then we can see in this case here, they're factoring out the a to use the distributive property backwards, which allows you to do 7 plus minus 3, which is 4, and the a stays connected. And here they're factoring out the b, all right? So the b comes there, and then you're left with 5 plus 4, which becomes 9b. So similar idea, just a little bit easier or cleaner way of going about doing that. And there are probably other ways of solving that, or other ways you can organize that, but that's what's kind of cool about solving expressions and equations. There are multiple ways to get the same solution. All right, let's move down to activity number 3, where it says making sides equal. We're going to replace each question mark with an expression that will make the left side of the equation equivalent to the right side. So here we have 6x plus something is going to get us to 10x. Now, there's a couple ways of going about this. I can pretend that I just have an empty space here, and I could subtract 6x from both sides to find out what this empty space is going to be equal to. So 10 minus 6 is going to be 4, and I have 4x. So what should go in this space would be 4x. I can also just think about 6 plus what number can get me to 10. Again, it's still an x, so we would say 4x there. So either way, whatever you kind of see, we would say number 1 is 4x. For number 2, again, if we have 6x plus something is going to get me to 2. Well, 6, and what do I have to add to 6 to end up at 2? I'm going down, right? So here's a number line. If here is 6, and here is 2, 3, 4, 5, 3, 4, 5, what do I have to add to 6 to go this way? That's going to be a minus 1, 2, 3, 4. So I'm going to have to go 4 that way. So if I subtract 4, or in this case really 4x, then I can get something that is equivalent there. So I subtract 4x. For number 3, here we are again at 6x, and we're going to add something in order to end up at a negative 10x. All right. So I need to end up with a larger negative number than what I have here. So I could do something like I did in the first one. I could subtract a 6x from both sides, and when I do that, I have like terms, or I have a same. They're both negative. Sorry. So because they have the same sign, I'm going to combine that to make a negative 16x. Well, that value is what's going to go inside my circle. So what I'm missing here is a negative 16x for number 3. Number 4 is a little different, and so is number 5. So let's take a look at number 4. Number 4 says you have 6x plus something is going to get you to 0. All right, so I want it to simply go away. So to make it go away and be left with nothing, I wanted to take away what I have, which is 6x, because 6 minus 6 is 0. So that's not too bad there. But then when I get to this one, notice that I have 6x plus something here is going to equal 10. There's not an x on this one, is there? So I need to eliminate the 6, but I also need to add a 10. So let's go ahead and add the 10 right here in this little circle first of all, because 10 is going to equal 10. So that's good, but now I need to make sure I get rid of the 6x. So let's put a minus 6x right here, and probably I'd put this in parentheses like so, and that would work out just fine. So I'd write a negative 6x plus 10, and that's what I would put in the space of that question mark there. All right. Let's check the other side, which is the B side, which again, you're probably doing this with your partner, and one of you did one and one of you did the other side. Now you're checking off to see who got them right and who got them wrong, or what do you have to change, or what's going to be. It's all part of the learning, lots of fun. Remember, talk about it and resolve any disagreements you might have as we do this one here. So here is 6x, and again, 6x minus something is going to get us to 2x. Well, what am I going to take away from 6 to get to 4? To get to 2, we would say 4x there. So 4x is what I'd use for number 1. Here, we're going to do a 6x, and we're again, it says subtract something in order to get to 10x. So because I'm going to be increasing from 6 to 10, I know I need to add something, but I'm subtracting a number. Well, how can I turn subtracting a number into adding something? If I subtract a negative number, say a negative 4x, this becomes adding the opposite. And when I add the opposite, that's the same as adding. So we would say negative 4x would actually work, because that becomes add, and we're back to 10. And the next one, 6x minus something, is going to leave you with just an x. So that's a 1 is what's left there. So what do I have to take away from 6 to get to 1? We would say 5x. That works there. And then here, another funny one here, we have 6x minus something is going to get us to 6. Well, that means I need to make sure I eliminate that 6x. So let's just subtract a 6x from 6x, and let's add 6 there. Okay, so that would work just fine if I left it just like that, which is 6x minus 6x plus 6 equals 6. That would work. If they wanted to factor a little bit, sometimes you might see something maybe along these lines. If I put a parentheses, I would do this, 6x minus, and if this is in parentheses, I would keep this as 6x to keep it negative when I distribute. And if I made this a minus 6 here, when I distribute that out, that becomes what? A minus times a minus is still a plus 6. So if you use parentheses, you would say this is an answer. If you didn't use parentheses, you would say that is your answer right there. So it depends on what you use, if you use parentheses or not parentheses. And then finally, we have a 6x minus something is going to equal 4x minus 10. Okay, so I know that I need to have a minus 10 on this side, so I can balance that with that, right? And I know I need to get to a 4x from 6. So if I subtract 2x, 6 minus 2 can get me there. Again, I can leave it as 2x minus 10, or if I want to use parentheses, I would have to do this as because I want that to be a negative 2x, I keep it at 2x there, and because I need that to be a negative sign, if I made it positive, again distributing, that would turn it into a negative once I'm done. So either one of these are going to be fine. Either with parentheses, it's 2x plus 10. Without parentheses, it's 2x minus 10. So again, that might be something you talk about with your partner, whether they use parentheses or not. Okay? And that's really what it is. So there are many ways to write equivalent expressions that may look very different from each other. And so we have lots of ways of doing that. So that's part of what today's lesson was. Let's take a moment to do your homework and let's check it together. All right, number 1. Andre says that 10x plus 6 and 5x plus 11 are equivalent because they both equal 16 when x is 1. Do you agree with Andre? All right, if these were equivalent, that would mean that 10x plus 6 equals 5x plus 11. That's what equivalent actually means. So that would have to be true. Well, let's subtract 6 from this side. Okay, let's subtract from both sides. 11 minus 6 is 5. And now let's put the x's over here. Let's subtract a 5x from this side and a 5x from this side. And so 5x equals 5. And then we have divide by 5, and x equals 1. So when x is equal to 1, they are equivalent. And that's what Andre is saying. That's where he got the idea of x being equal to 1 works. So it works when x is 1, but is it true for all values of x? That's the question. Yes, it's true when x is 1, but what if you change the number? What if x had a value of, let's say, 0? Again, I like to use 0 because it's simple. So 10 times 0 plus 6, is that equal to 5 times 0 plus 11? 10 times 0 is nothing, okay, so we're left with 6. And 5 times 0 is nothing, so we're left with 11. Does 6 equal 11? We would say those are not equal, so 0 does not work. Okay? So that means that these are not equivalent expressions. Yes, one works, but they're not equivalent because it's not true for all values of x. All values of x do not make both equations the same, so it's not equivalent. On number 2. It says select all expressions that can be subtracted from 9x to result in 3x plus 5. So this is a good question, and you do have to think about it a little bit because we're going to take whatever this is and we have to subtract that from 9x. So here's what I mean. So here's a. For a, it's 9x minus, and let's put it in parentheses, minus 5 plus 6x. It's really important that you put that part in parentheses there so that you can distribute appropriately and see if it results in 3x plus 5. When I do this, I have 9x, and minus times minus 5 becomes plus 5, and a minus times a negative 6x becomes negative 6x, and I can combine these together, or I could rewrite them, which is what we've been doing, 9x plus 5 plus a negative 6x. Then I can use commutative property, move things around. So 9x plus negative 6x plus 5. These now can join together. 9x plus negative 6x is 3x plus 5. So I do arrive at something that matches that. So A would indeed work. Okay, let's look at B. B, we have 9x minus, and we put that in parentheses, 5 minus 6x. So again, we're going to bring down the 9x, we're going to distribute, so that becomes minus 5, and this becomes a plus 6x. So a 9x and a 6 plus 6x together combine to give me 15x minus 5. That does not work, so it's going to be a no. No for B. For C, we have 9x minus, parentheses, 6x plus 5. Again, 9x comes down, we distribute, so that becomes a minus 6x. Distribute becomes minus 5. So 9 minus 6 is 3x. That's good, but then I have minus 5. So that is also going to be a no. For D, we have 9x minus, parentheses, 6x minus 5. So we have 9x there, and we're going to distribute. That becomes minus 6x. This becomes minus times a minus is a positive 5. We can combine 9 minus 6 to make 3x, and then we still have a plus 5. So that's going to be something that does work. It matches there. And our last one, choice E, we have 9x minus, and in parentheses, negative 6x plus 5. We're going to bring down the 9x, distribute, so that becomes a plus 6x, and then minus 5. So 9 plus 6 becomes 15x minus 5, and that is also going to be a no. All right, number 3. It says select all the statements that are true for any value of x. All right. So basically that would mean they're going to be equivalent when we move things around a little bit here. So let's look at A. A, I could combine a 7x and a 2x to give me that 9x, and I still have the 7's which match there, no problem. So this would be true for any value, no problem. When I look at this one, I have 7x plus a 2x minus 1. So this can be rewritten as a plus a negative right there, all right, plus a negative. If I combine 7x and 2x, that works for the 9, but because I have this minus 1 and I have a plus 1, that's not going to work out too well. So it's not going to be true. Here on this one, if I rewrite this one here, I have a 3x and I have a minus 3x, so those are going to be eliminated or cancel each other out. So what I'm left with is 10 equal to 10, and that would be a true statement. On this next one, if we distribute the negative through, we end up with a negative 8 and a positive 6x. Okay, is what we end up with when we get rid of the parentheses there. So now a 5 and a positive 6 becomes 11x there minus 8. Is that equal to negative x minus 8? We would say no, not going to work. This next one, distribute the negative through, you end up with it, let's set it equal to this one, so we'll set it with 4x minus 2x minus 8. So let's see, 4 minus 2 becomes 2, that matches, and minus 8 minus 8, so that's going to be okay. Alright, and this last one, 4x plus 4, let's see what happens here when we distribute. We still have the 6x, distribute the negative 2, so that becomes a minus 2x. Distribute the negative over there, so it becomes a plus 4. So 6 minus 2 is 4x plus 4, and those match there, so that would also be true. Alright, for each situation, decide if you would use x less than 25, x is greater than 25, x is less than or equal to 25, or x is greater than or equal to 25. The library is having a party for any student who read at least 25 books over the summer. Priya read X books and was invited to the party, so she made it, which means whatever she read was greater than or equal to 25 books, because you had to have at least 25 to get to the party. Kieran read X books and was not invited, so we don't know how many she read, or he read, sorry, but we know it was less than, whatever he read was less than 25. Couldn't even be equal to. If it was equal, he would make the party, but it was less than 25. Bummer for them. Here we have a filled in circle at 25. So whatever values we have, they're going to be less than or equal to 25, because it's a filled in circle right there. And then on our last one for that number right here, we have an open circle. Open circle means that x is going to be, in this case here, greater than 25. It's just greater than with no equal sign because it's an open circle. Okay, and finally our last one, number 5, consider the problem a water bucket is being filled with water from a water faucet at a constant rate. We want the bucket to be full. What information would you need to know to be able to solve that problem? Well, a couple things. You'd probably need to know the size of the bucket, right? Whatever the size of that bucket might be. Okay, you'd probably want to know how the height of the bucket for, you know, how high up it has to go before it is full. You would probably want to find out, okay, what the water flow rate's going to be, so you would know how quickly it's filling up. So those are all things that you'd want to know, be able to figure that out. And there's probably some other things too, but you can write those down on your own. That's it. We'll see you next time.